Hi netizens, this is the second part of the trigonometric quadrant. Now I'll be able to pick some related questions based on what I've treated in the previous video. Let's take for instance, a question of this nature is given. If sine theta is equal to 0.5. Take note, in our quadrant, we did not only take note of that of the first word, quadrant, which shows all trigonometric functions to be what? Positive. We also consider the second quadrant, that of the third and fourth. So in this case, I'm going to extract the range to be from 0 down to what? 360 degrees, because that is what a complete circle gives us. Now we have, probably we can say 0 degrees is less than or equal to theta, which is what we have here, then less than what? 360 degrees. This implies that the range is from what? 0 to 360 degrees. In that case, we have to solve sine theta equal to 0.5, which is the same thing as what we have here. So let me quickly erase this one. I think we're okay with this question. So what we quickly do is we want to obtain the angle that this sine theta gives us as what? 0.5. Remember, we have to get the what? The sine inverse of 0.5. That is just what we need. But it also goes beyond that, because whatever we get in most cases, or will I say in all cases, we tend to get the first what? Quadrant. So because this ranges from 0 down to what? 360, we also need to get the what? The next value of this theta, because sine is positive in the first quadrant, sine is also positive in the second quadrant. That is what that S denotes. Then here is T, and here is what? C, where you say all students take calculus. Funny enough, you also hear some students say all science teachers are crazy, but I won't encourage you to say that. Okay, now at this point, what I will do is indicate the solution. Then I'll have sine theta is equal to 0.5. So at this point, I will need to divide both sides by sine. But that sounds funny. When you intend to divide both sides by sine, it means you have to take the what? Sine inverse. So taking the sine inverse of this, I'll have theta to be equal to sine inverse of what? 0.5. So by the time you punch sine inverse of 0.5 in your calculator, you get the value of what? 30 degrees. Yes, 30 degrees there is one of the special angles, okay? 30, 45, 60, then you have what? 90. These are special angles. So theta will be equal to 30 degrees. So this represents the first quadrant. Of course, remember the first quadrant is from 0 to what? 90. And 30 is below what? 90. So this is where the sine falls. So I'll call this one my first quadrant. First quadrant. Then how do we get the second quadrant? Don't forget this expression. The first quadrant is theta will be equal to what? Theta. Then second quadrant will be 180 degrees minus what? Theta. Then the third quadrant is what? Theta minus 180 degrees, and the fourth one is what? 360 degrees minus theta. So you work with this, then ask yourself, where does this sign fall, or where does this sign become positive aside the first quadrant? Of course, it is in the second quadrant. And what is the expression given, or will I call it the formula? Yes, it is 180 degrees minus what? Theta. So I'll plug it into this equation. So 180, or let's say second quadrant will be equal to 180 degrees minus theta will be equal to what? This 30 degrees. Then I'll have to add theta to both sides, then subtract 30 degrees from both sides. So what I have here becomes 180 degrees minus 30 degrees, which is equal to theta. So what is the value of theta? That becomes theta to be equal to 180 degrees minus 30. Of course, this is 150 degrees. Considering this, we can now deduce that the value of this theta in the first quadrant is what? 30 degrees. Then second quadrant is what? 150 degrees. So that is how you apply this kind of what? Question. Thank you. More questions on the way.